Hi everyone, we're just waiting for people to join, so I'll just give it another minute before we begin. Okay, so welcome to today's webinar, Unlocking the Power of AI with Edge Impulse Studio and Renesas RZ V2L. Today we are joined by Stefan Ungrecht from Renesas and Omar Schritt from Edge Impulse. In today's webinar, we'll be running through the Edge Impulse platform to start with. We'll also go through the RZ V2L. We'll show how the integration happens with the hardware. Omar will show you a live demo in Edge Impulse Studio, and then we'll go to a Q&A. So if you have any questions, you'll see at the bottom there's a Q&A section. If you put any questions in there, we'll either answer them through the webinar or we can ask the speakers at the end. So with that, I'll pass over to you, Omar.
Hi everyone, my name is Omar and I am a solution engineer at Edge Impulse, and I have been working with Stefan in the last year to complete the integration of the RZ V2L to the studio. So today we are going to see that during the webinar, and feel free to ask any questions at the end of the webinar. Stefan, please. You're muted, sorry.
Yes, hello. My name is Stefan Ungrecht. I'm application engineer at Renesas Electronics. And yeah, as Omar mentioned, we are working together to have the solution RZ V2L with Edge Impulse. And yeah, this is what we want to talk about today. Yep, sorry. Yeah, it's my pleasure to start with the introduction of the RZ V2L hardware. It contains an AI accelerator IP, DRP-AI, and we will spend the next 10 minutes to go through a few more details. First of all, we are talking about RZ V2L. This is a general purpose MPU for industrial applications. It contains the DRP-AI artificial intelligence accelerator IP, and that's why we call it a Vision AI MPU. But industrial applications have dedicated requirements. This is not only the performance. Here we are talking about power consumption. Power consumption is very important to take into account. Think about heat emission. Think about cooling requirements, BOM costs, and especially for battery-driven devices, it is very important to think about the power consumption. Accuracy is important as well. We have high requirements for reliability and the quality of the inference results. Maintenance is another cost factor. Think about a device that is running for several years in a factory. We need to maintain the software, and also this needs to be taken into account. Next slide, please. Yep. So our RZ family is a bunch of general purpose MPUs with different target applications. It's very diverse. Think about surveillance cameras, retail gadgets, robots, service robots or factory robots, office equipment, drones, medical devices, and so on. We differentiate two different classes. The first one, we call it entry class. These are the general purpose MPUs without AI accelerator. This are the V2L family or devices. Here the inference can run on the CPU, and we have a neon unit that can be used to accelerate artificial intelligence as well. But the higher performance is given by the DRP-AI, our accelerator IP for that we want to introduce now. Today we are talking about V2L. Yeah, this is a kind of benchmark. You see, we have a scalable solution. When we start from G2UL, here we have a single core Cortex A55 with this neon unit, and the processing running on the neon unit, for example, MobileNet V2, achieves 10 frames per second. For G2LC or G2L, we achieve 18 frames per second. And due to the accelerator, the DRP-AI, with floating point 16 arithmetics, we achieve 43 frames per second in V2L. V2M is a bit faster. Oh, sorry. Yeah, thank you. It's a bit faster. It has a higher frequency for the DRP-AI and a bit higher bandwidth, so we achieve 70 frames per second for MobileNet V2. Yeah, this is the architecture, very rough. It contains the DRP-AI module or IP contains two blocks. The first one is a DRP, the dynamically reconfigurable processor, and the second block is the AI MAC. MAC stands for multiply and accumulate, and the MAC unit is used for the convolutional layer, and the DRP takes care for the nonlinear functions like pooling and other layers. The whole neural network can be processed with the DRP-AI, and the DRP-AI has a few more features to increase the performance and to reduce power consumption. For example, we have a buffer to reuse the input data. There are switches to avoid zero data processing, and we have a controller to optimize the operation flow. If you want to have a more detailed look, please check the white paper or additional information on our website. The MAC unit contains of 576 MACs. It's running with 400 MHz in V2L, 630 MHz in V2M. We have a 16-bit floating point unit, or 16-bit floating point arithmetics, and we achieve 1 TOPS per watt. Yeah, coming back to the hurdles of industrial devices. First of all, power consumption. We have the DRP-AI with the high power efficiency. We do not need a heatsink for V2L. We have the 16-bit floating point arithmetics that allows to keep the precision, the accuracy of the prediction. And I didn't touch it in detail here, not enough time today, but the DRP can also be used as an image signal processor because it's simple ISP, simply to increase the input image quality. And this helps to use inexpensive cameras and especially increases the quality of the inference result. Last but not least, we have the Renesas verified Linux package that is based on the CIP kernel and maintained for more than 10 years. So now let's talk about the implementation flow. You can imagine the DRP-AI is a complex IP. We need additional software to map a neural network to it. And here we use the DRP-AI Translator. The concept is simply that we translate a neural network from ONNX format to so-called DRP-AI object code. On top of that, we are able to add the pre- and post-processing. So, for example, image cropping, resizing, and so on can be accelerated by the DRP-AI as well. On top of that, we have the graph optimization that it is more or less this optimization of the processing flow. It is not modifying the neural network. Yeah, and last but not least, the quantization to 16-bit floating point. As you know, we start from 32-bit floating point, and the quantization to 16-bit floating point has almost no impact for vision AI. Yeah, this is the flow that we support from Renesas. The idea is that the flow starts from a already trained neural network. The DRP-AI translator translates the neural network to DRP-AI object code, and this object code is processed at the device. On top of this, we have DRP-AI TVM. This is quite new released. This allows to, let's say, process the neural network on the DRP-AI in some kind of hybrid mode, where also the CPU is involved. At the end, the flow is the same. So it's simply, we need a translator from a pre-trained neural network. So this flow changes now with Edge Impulse. If you see, as you can see here, the flow is much more simplified. It's possible to fetch data from the device, prepare a data set, train a neural network, and finally deploy it back to the device. So there's no need to dig into the AI frameworks or the DRP-AI translator and so on. It is already implemented. And that's the point where Omar can take over, please.
Thank you. Thank you very much. Yes, indeed. So Edge Impulse in itself provide you with a platform, a cloud platform that allows you to collect data sets from any devices that is supported, and especially the RZ V2L, and we are going to see that today. If you have already data set that is located in the cloud or on any cloud service provider, we can also fetch the data set and provide it to the Edge Impulse Studio. Then we can design a machine learning model using DSP part, and then NML embedded frameworks such as TensorFlow Lite, and also you have a very simple interface to work on it using Keras Python code. Then after training the model, we do the testing, which is evaluating the performance of the model with the testing sets to be sure that the model has the highest performance. And eventually we deploy the model back to the edge devices. And also from the edge devices, we can also evaluate the performance, and we can recollect a data set and push it back to the edge environment. We are going to see more in detail about the data set. So, as I said, we provide you with a lot of possibilities to integrate the data set from any environment that you have. If you can upload your data set, if you have it locally, if you have it in the cloud. We also provide you with a data exchange portal. So you can put your data set and provide this portal to a third party where you can add a data set and integrate it to Edge Impulse. We also provide a nice tooling such as the auto labeling tool, where you have a huge amount of data set for object detection, and you'd like to label this data set. So you can use a pre-trained model that we have, and you can label all the data set really quickly. So, we are going to see all of these one by one during the live demo. The second thing, which is really interesting, is the training of your machine learning algorithm. So today we are going to see object detection, where we are going to train a machine learning model that is going to detect faces. So we have to use a DSP algorithm, which is doing normalization for the images. And then we are going to use Keras framework to train the model. All of our DSP algorithms are open source, and they are hosted on GitHub. So there is no black boxes. Everything is open. You can go and see the code yourself. And also you can modify it, and you can submit your own data processing block into Edge Impulse and use it instead of the one that we are providing. For the ML blocks, it's exactly the same. You can provide your own machine learning model that you'd like to use. We have also a new feature which is called Bring Your Own Model, and we have a set of documentations to show you how to do that. So today we are going to see the RZ V2L. Everything is going to be related about this board. I have already the board connected to my laptop. If you'd like to see it, this is the board. This is my own setting. I have connected the Google Coral camera to the board, which is here. I have also an Ethernet cable connected to the board to provide an internet connection. There's two USB cables connected. The first one is USB-B cable, which is providing a serial connection to the board. And the second one is USB-C cable, which is providing power to the board. To power the board, there is a red button, which is already clicked, and the board is already on. Also, there is a possibility to use an SSH connection to connect to the board. But in this session, I used a USB-B connection for serial connection. So this is the board, it's live, and it's connected to my laptop. Let's go back. Yes, so the board itself has the DRP-AI hardware accelerator, which is providing really a high performance. And as you have seen, the board doesn't have any heatsink, and you are going to see a real performance on the board today in a few minutes. So the project we are going to see is about face detection. The images are already uploaded to the studio and already labeled. I have already provided I have already trained the model, but we can do a sub-training just to show you how the training is happening. So we are going to connect the RZ V2L. We are going to use the Edge Impulse CLI to connect the board to the Edge Impulse Studio. And we are going to sample a couple of images, and I'm going to show you how to label these images using the studio. Then we are going to train a model, and we are going to eventually deploy this model back to the RZ V2L. And we are going to show the inference in real time. Perfect. So let's see the studio and connect the board. So this is a project that I have mentioned. If you are familiar with Edge Impulse Studio, first you will have, if you are going to sign up, then you need to create a project. When you create a project, you provide a title, and you need to provide a dataset. So the first thing you are going to see is the dashboard, and it's going to be similar to this one. You can provide more details for the README, so you can describe the project, what is it about, what you are trying to achieve, and you can make the project public or private, and it's up to you. You can add your colleagues in here as collaborators, where you can they can also train the models, deploy it, and do exactly the same thing as you. You can see the summary related to the number of devices connected to your project and the amount of data set that has been collected. Now we have one device that is connected, but if you have more and more devices, the number is going to increase. We have a project ID also to identify your project, and there is a labeling method. In this case, we have bounding boxes because we are trying to do object detection. Otherwise, if you are trying to do image classification, you need to select one label per data item where each image has its own label. The target device is the Renesas RZ V2L. You need to select this device in order to have the computation. The numbers such as the RAM and ROM computations are done for the RZ V2L and not for a different target. So you can see the estimation of the speed, and memory usage on the device as well. This one is called the download block, where we provide you with a very simple way if you'd like to do some kind of local testing. So you have your data sets, you provide the data set to the studio. And then from the dataset, we create an NumPy file. So you have all of your dataset is in one NumPy file where you can test it if you have a Python script that is locally hosted, or if you have, let's say, any other environment you need to test. So you can use the NumPy file. We provide also the labels, and we provide you with a model. This one is the model that has been trained. So at the end, everything when you finish the training of the model is going to appear at the download block. And this one is only for testing purposes. So it's not the model that we deploy to the device. So it's only if you'd like to test it with your Python script, but this is not the model that is going to run on the hardware. So the next step is we go to the devices. Currently, this device is not connected. When it's connected, so if you'd like to connect the device, we go to the terminal. I have already established a connection to the RZ V2L using serial connection. So to connect the RZ V2L to the Edge Impulse Studio, we use the Edge Impulse CLI for Linux. We have two CLIs, one for Linux and one for microcontrollers. Since the RZ V2L is a Linux board, we need to use the Edge Impulse Linux CLI. So start the Edge Impulse for Linux, you need to install it using npm. I have already installed it, and to start it, just you need to write edge-impulse-linux. You click on it and you wait for a couple of seconds, and then it's going to ask you for your credentials. I have already provided my credentials, so it's going to connect immediately to Studio. It's going also to detect the sensors, and then it's connected to your project that you have already selected. If we go back to the, yes, so we see that the device now is connected, and last time I've seen it is now, and you have the ID of the device, and you have the name of the device as well. Now we can go to the data source. This is an interesting feature. If you have a huge amount of data set that is hosted on, for example, Amazon Web Services, or any cloud environment, and what is interesting in here is that you can create a pipeline that is automating the entire process of training and deployment, and everything that is related to the thing that you do on Edge Impulse. So basically, we can automate the entire process from dataset collection to the deployment. To do that, you need to select, what is your cloud provider. In this case, I'm just going to say, don't import data, because I have already dataset in here. But if you have datasets hosted on Amazon S3 bucket, then you need to click on the one that is there. The next step is you need to set up what you'd like your impulse to do. You can create the data explorer. You can ask it to retrain the model and create a new version, and then to deploy the model. All of these can be selected, and we can, at the end, if everything is good, you click on create pipeline, and you'll have your pipeline in here. It's very nice, very simple. This one is going to run once a day. You can customize it, and you can see which step is happening at what time. You can also modify it by click on edit pipeline, and you can see how to modify the pipeline. Also, you can select when you get a notification, and by email, and you can modify anything. So this is how you create a customized pipeline. Okay, I'm not going to run it now because I don't have any data set to import, but just to show you how it's done. So let's go to the data acquisition. When you upload your data set Edge Impulse, if you have it locally, you need to click on upload existing data set, and in itself, it can automatically split between the training and testing, but you can specify whether if you'd like your data set to go to training or testing. You need to provide labeling file, which is called the bounding _boxes.labels. If you don't have this one, you can upload your data set and then you can label it using the labeling queue, which is in here. If you go to the training data set, you can see each one of these data sets elements one by one, and you can see that this data set is labeled, and where you can see where the bounding boxes are. If you'd like to collect more data sets, you can either upload it from your device, or you can collect it immediately, from the RZ V2L, which we are going to do right now. I have the device connected. The device is connected, and it's detected by the studio. We can, give it a name. It's called face, and the sensor is the camera sensor that is connected, and you can see immediately the camera feedback. If I point the camera back to me, I can see my face. Yeah, it's very hard to point it the right direction. Good. I'll start sampling. And then, I have at least one photo. It's going to appear up here, so you can collect as many samples as you like. This one, it's not labeled, so let's go and label this one. You can see it appearing in the labeling queue. Click on the labeling queue, and you click on the face, and you click, well, it's a face, set label, and now it's labeled. There's two ways of labeling. You can classify using YOLO V5. So if you have a huge amount of data set with complex, a lot of things to label, then it's easier to do that. Or if you have like a video, and then what you can do is you can cut the video into images, and then you can choose to track objects between frames. And it's very simple. You label the first image, and since the second one is just a frame from the video, it's going to be the consequent second image from which is following the first one. So the labels are going to be exactly in the same place, and you can just verify that the labels are correct, and you can save the label. If we go back to the training data, you can see the last one we have added is in here, and it's also labeled. We also have testing sets, which is we use it to test the model to verify that it's connected, and it's like the model has the highest accuracy. Yeah, so I think I have covered everything related to the data acquisition. If you have any question, please leave it on the chat. Yeah. Yes, we can also export the data sets. So all the data set that you have, you can export it from Edge Impulse, and you click on export, and you'll have the data set as a zip file that you can use locally. Let's go to the impulse design and see how we are going to build our machine learning model. First of all, we need to define the width and the height of the image that is going to be fed to the neural network model that we are going to train. You can set the resize mode as a way, as it seems to be the most adequate. The second thing we need to do is to specify our DSP. In this case, we need to specify the image DSP, which is the image digital signal processing block. There are, the Edge Impulse Studio is going to recommend a set of DSPs depending on the dataset type that you have. In this case, we have the image one. If you add a custom block, you can click on this one to add another one, and you can see it in this list. But if you have different kind of data sets, there is another set of DSPs that you can use. But for today, we are going to use the image DSP block to do normalization of our images. It's exactly the same for learning block. There are a set of learning blocks. So we need to select the object detection block, and there is also a different set of other block for transfer learning. For images, if you're doing classification, then you need to select the classification block, and so on and so forth. For me, we need to select the first one, which is the one that is recommended because we are doing object detection. Once it is done, we click on Save Impulse, and then we go to the image. Where from here, we can see the last image that we have added. This is the raw features. And here we see the processed features, and this one are the normalized features of the image. And you can see the on-device performance. And this means that it's going to take 2 milliseconds to process the DSP block is going to take 2 milliseconds to do the normalization on the RZ V2L. And it's going to consume a maximum of 4 kilobytes of RAM to do the normalization of the image. We go to general features. One thing I forget to mention is the color depths, where you can flip the images and you can select grayscale, and you can train a model that is only going to detect grayscale images or work on grayscale images. For today, we are using RGB. So Data Explorer. Once you have generated the features, I click on generate, and then you end up having something called the Feature Explorer. It's interesting to see the Feature Explorer because it's going to show you the distances between the features, and basically it's showing you the distances between the images and how different they are to one another. This one is interesting if you have really complex data set, and it can tell you, if you have several things that you are trying to detect, you will see different set of clusters, and each cluster has a unique color. And from there, you can, identify what kind of machine learning model that you need in order to be able to have the highest accuracy. So if the clusters are really far, then you need very simple model to, separate these clusters. So you don't need very complex model, but if the, clusters are interconnected and the colors are everywhere, so you need more complex model, more complex neural network to be able to separate all of this one. So today, we are only trying to detect faces as an object detection. So we have only one cluster, and showing you this entire cluster, how it's, how it's separate in the this environment. So we have already seen the on-device performance. It's exactly the same. So let's go now and see how we can train our model. So we have the number of training cycles that you need to define, and also the learning rate. The lower your learning rate, the better your training is going to be. You also need to set up the size of your validation set, which is the part of the training data set that we are going to use to verify the accuracy during the training of your model. You need to select a model. For this one, we have selected FOMO, which is our Edge Impulse object detection model, which is called faster objects, more object. You can choose a different kind of of FOMO, or different kind of models. On the RZ V2L, we support now YOLO V5, and also we support the MobileNet version 2 SSD in addition to FOMO. So it's up to you to choose which one you would like to use during the training of your model. Once you have selected, then you need to click on Start Training, and eventually you'll see the training output, and you'll see the training performance at the end with the F1 score that we have here, and also you see the model version. Also, you need to select the Renesas RZ V2L from here to be sure that the model is going to be the model that you choose to train is compatible with the DRP-AI. So you need to be sure that you have selected the target from up here. Also, we see the on-device performance. This is telling us that the FOMO, when it's going to run on the RZ V2L, is going to have an inferencing time of around 3 milliseconds, and you're going to see a peak RAM usage of about 5.5 megabytes, and similar thing for the flash usage, which is the size of the model itself. Yes, so usually I can show you the deployments. We also have like classification and model testing, which you can evaluate the performance of your model. But let me show you the deployments what we have here. So when you'd like to train your model, when you finished, You verified the accuracy of the model, you are satisfied with the accuracy. Then now it's the time to deploy your model on the RZ V2L. To do that, we have three options. We have two options in here. The first one is the DRP-AI library, which is providing you a C++ library with the code that is going to run on the hardware accelerator, which is the DRP-AI in this case. Also, we provide you a firmware. So if you don't want to get the code, we provide you with something called the EIM model, Edge Impulse model. And the Edge Impulse model is compatible with the CLI that I used, to connect the board to the studio. So you can use the Linux RZ V2L.eim and click on it in here, and then click on build. Now the studio is going to take the model that you have trained, also take the C++ library, and compile the entire model and produce an .aim model that you are going to download, and then you can take this model and put it on the RZ-V2L to do the inferencing on the device. Our complexity related to the DRP-AI translator on a NIC conversion and all of that is done at the studio, so you don't need to try to understand what's happening. You just need to take the EIM model at the end and use it immediately with the CLI. If you have an application that is already running, you can use the DRP-AI library and integrate the code, the C++ code with your application and run it also on the device. So this is the phase detection model .aim, and let's go now and run this model on the RZ-V2L. So yeah, one thing to cover before, just to explain what happened here. Since I sampled one image from the RZ-V2L, you can see that there is a sampling request where you see the output, where the Edge Impulse Linux sampled one image. So all these things related to the label, the length, and the sensor, which one is used, and the HMAC key that has been used. Then it's uploaded and the sampling has finished. So each one you sample, you will get an output similar to this one, telling you that there has been a sampling request on the device in itself. Okay, so now I need to use a different CLI to do the inferencing. So I click on Ctrl+C to stop this one, and then let's start the other one. So the other CLI is called Edge Impulse Linux Runner. There is two ways. Either you start the runner itself, and it's going to connect to the Edge Impulse Studio and going to pull the EIM model from the studio, so you don't have to do anything. Or what you can do is you can download the EIM model from the studio and then send it using SCP to the board and specify it using the model file. So the first one, you just don't specify anything. You just start Edge Impulse Linux Runner. The other one is you need to specify where the model file is located. I have already downloaded a file and put it on the device for you. So we are going to show you the second way of doing it right here. Once I have specified, I need just to click enter and wait for a couple of seconds. Perfect. So we can see the feed from the camera and see the live classification. We have a small web server that is located in this address with this port number. So you can go there and see it. You can see the feedback from the camera. Yes, this is it. I think it's live. Or let me, yes, it's live. Perfect. So I can show you the camera now. If you point the camera toward me, like that. Yes. So we can see that the model is able to, detect my face, and it's showing you the probability of, this is a face, and yes, that's it. If you go back to the CLI to see what's happening in there, we click back on the terminal. Yes. Okay, let's stop for 1 second. You will see the bounding boxes, and in this case, it's going to show you the height and the height and width of the image, showing you the label, which is a face, what the CLI has detected. This is the value of the prediction. It's like it's 70% sure that this is a model. This is the width. Sorry, it's a face, and this is the width of the related to the height of the image, and it's the coordination also of the face on the image. If it detects like 2 faces or 3 faces, you will see. So this is a list, and you will see like this is the first one, and this is the second one. So it depends on the performance of your model. And this one has only 400 images, so it's really small model that I have trained for this webinar. But if you train really if you'd like to have really high performance of your model, then what you need to do is upload a lot of images, do a lot of add also background images for different possible backgrounds, and also you need to add let's say 4 or 5K images and see the performance of your model. If it's fine, then it's good, but if it's not more, you need to add also more and more images. So depend on the performance of your model, depend on the number of images, type of backgrounds that you have, and a lot of parameters that you need to select. This one has, let's say, good quality, like between 70 and 80%. So it's able to detect faces, but it's not the highest quality. You can achieve that by adding more and more images. Yeah, so this was, I think, all about the live demo. Let's go back to the slides. So please, if you like any help and support, how to use the RZ V2L, how to use the Edge Impulse Studio, how to connect the RZ V2L to the studio, how to deploy back on the RZ V2L, please let us know. There's a forum.edgeimpulse.com that you can access. You create an account and you ask questions. We have a full developer real engineers team that is available for you and are here to help you. And just ask us any questions, and we are here to give you direct help and support. We have also a couple of examples on Edge Impulse website. If you'd like to use it, the first one is about counting the retail inventory, and the second one is the monitoring the also retail checkout lines. This one are available. If you'd like, go check them on the Edge Impulse documentation website. There are another 2 examples are also available, or they are going to be available soon. The first one is the pose estimation, and the second one is about the vehicle detections. Yeah, please have a look and see, a lot of applications are possible. So please, sign up to Edge Impulse if you never tried the platform. It's amazing. It's very simple to use. We have documentation on everything, and you have also the forum, so you can use it. Get also the RZ board. I have added a link where you can get the board, and to have one of these, the AVK kits. We have also documentation specifically for the RZ V2L board that we have elaborated and added to our website to guide you through this process. So thank you very much for today. Please let us know if you have any questions.
Thanks, Stefan and Omar. We have got a couple of questions come through. The first one is for you, Stefan. DRP-AI uses 16-bit floating point. Why not quantization to 8-bit integer?
Yeah, as said before, the DRP-AI consists of 2 blocks. The first block is the DRP, the dynamically reconfigurable processor, and that is used for nonlinear functions. And for these, the floating point is really required. We have a 576 max, so it has been decided to keep the accuracy by also implementing these max with 16-bit floating point. The next generation of the DRP-AI will have some kind of hybrid architecture. So the DRP will still remains with 16-bit floating point, but the Mac unit will have a 4K max with integer 8 arithmetics.
Thank you. Another question that Marcus has just popped into the chat. Is this studio suitable for other than imaging applications as well?
Would you repeat the question, please?
Yeah, I think is this studio suitable for other imaging applications as well?
What do you mean by imaging application? Basically, you can any image that you are adding, you can do image classification, or you can do image object detection. For image classification, also you need to label the images. So each file has its own label. Object detection, you need to provide a file that has labels, and then or you can label on the studio itself. Other than that, you can train a model to do either image classification or detection, and then you can deploy it back. Does that answer the question? Or
hopefully. Okay, another question. Do the examples also run out of the box on the new RZ V2L board from Avnet embedded, or do they need to be modified?
I tested this already.
So the RZ board from the Avnet, if you have the npm package installed on the RZ board, then it should be fine. You can immediately install the CLI. If not, you need to compile the Yocto build, and you need to go to the Edge Impulse documentation there. We have added the way you need to modify your Yocto let's say your Yocto configurations in order to add the npm installation, and then you need to compile the Linux image and put it on the RZ board. The Avnet board, also, I gave it a test as well. You should be able to use the CLI. You should be able to use any C++ application with the DRP-AI library and do also the inferencing. It's exactly the same. You just need to be sure that the npm package is installed on the RZ board.
Okay. Will the software run on the other RZ V2L boards as well?
Yes.
Okay. Omar, can you explain about the Eon tuner?
Interesting. Okay, let's go back to the Ion tuner. I have prepared some kind of yes. So sorry. So the Ion tuner in itself provides you with really simple way to do AutoML. So if you don't know how to choose, the configurations for your, image DSP block, or for your transfer learning model or the FOMO model, you can select the Ion tuner. You need just to upload your data sets and configure the Ion tuner. You provide to the Ion tuner the target device. What are you trying to do, which is, image classification, or, what is the application, and also the referencing time. You select you start the Ion tuner, and then the Ion tuner is going to run on the background. It's going to take, from, let's say, 5 minutes to a couple of hours, depending on the size of the data set that you have, and going to provide you with the set of models. They are listed by the highest accuracy to the lowest one, and you can select the model with the highest accuracy if you are satisfied with the model. So you also can filter, and you can also select what is the view and what is the sorting. So you can choose the model that have, the models that have, let's say, the lowest inferencing time, or the lowest RAM and ROM usage. So it depends on what you select. Currently, for object detection, it's coming soon. We don't support immediately for object detection, But for now, image classification is supported with the Ion Tuner. So yeah, we have like an experimental version of object detection, but it's not yet public. So we're working on it. But for image classification, it's already public. The RZ V2L support image classification. So we have ResNet supported, and also we support a couple of other, models for image classification. I have already added a list in our documentation of these models, and you can see the list in here. All of these MobileNet model are supported and are going to work on the RZ V2L board. So if you'd like to do image classification.
Great, thank you. Is the RZ V2L openly supported, or do people need to have an account with Renesas?
I think this is for Stefan.
Okay. Yeah, it is openly supported since end of November. You can access it directly without Renesas account.
Perfect. And then a follow-on from the question earlier about the AVNet side of things, the AVNet board. Will you please document the exact packages to be installed?
Yes, go to Edge Impulse documentation at Edge Impulse, then you go to supported board. From there, there is the CPU and supported board. You then select the RZ-V2L, and you will see the entire documentation. From there are listed two packages. The first is no JavaScript, and then the second one, I think, is no JavaScript npm. I can't remember for sure, but it's listed on our documentation. You need to go to RZ-V2L documentation on Edge Impulse, and you'll see it there. It's straightforward.
Thank you. How would you go about implementing an object tracking application? Are there any models already available?
Would you elaborate more on the question?
That's all I have at the moment.
So if I understand the question correctly, let's say if I would like to use a different model, any kind of model that I need to use to build like a machine learning model and then do object detection on the board. Well, we have a set of supported model that is here. So you need to choose one of the supported model. In the future, we will have, more supported model are going to be added. What you need to do is you need to have a C++ library. You deploy the C++ library from there, and then you integrate the DRP-AI library into your application. And once you do the integration, then you will be able to run the object detection model on the device.
Thank you very much. So the example there was with an object tracking camera.
I'm not sure yet if you support. I think yeah. Yeah, I think we only support this one right now for object tracking. Yeah, it's depend on the model. You can bring your own model of object tracking onto Edge Impulse. From there, you can see if the model is going to be translated for the for the RZ-V2L board, and then you can deploy it. Yeah, you have a feature now called bring your own model, BYOM, where you can select take any model that you have locally and upload it to Edge Impulse. Yeah, and you'll see if it's going to be translated, with the because the Edge Impulse Studio is going to do all the translation for the DRP-AI in the background, and if it's successful, it's going to tell you that you have the hardware accelerated version. If not, you're going to have a version without the hardware acceleration, and then you can deploy it to the device.
Yeah, I think here the focus is on the neural network and how to train it. And for tracking, the application needs to, let's say, use this neural network and really track the object. There are examples on our from our partner website. Or maybe we can share this later. But here with Edge Impulse, the focus is on the neural network at the moment.
Okay, thank you very much. Right, that seems to be all the questions for now. So is there anything that Stefan or Omar you'd like to finish up with? No?
That's all from my side.
All from my
Okay.
side, and thank you very much for attending here.